Let's try to evaluate an integral using the definition of the definite integral. The first thing we have to find is delta x. Let the limits of the integral be the values of a and b, where a is the lower limit and b is the upper limit. So we have delta x is equal to b minus a over n, and when we substitute our values for a and b, we get 3 over n. Now, since we are finding the right endpoint approximation, we need to calculate the function values at the right endpoint of the interval from xi minus 1 to xi. We know that xi is equal to x0 plus I times delta x. Substituting, we get 0 plus I times 3 over n, which is equal to 3i over n. Now let's calculate f of xi by substituting our expression for xi into the integrand. So, we have 4 times the quantity 3i over n cubed minus 3 times the quantity 3i over n squared, which simplifies to 108i cubed over n cubed minus 27i squared over n squared. Substituting this expression and delta x into the Riemann sum and then simplifying, we get 324i cubed over n to the fourth minus 81i squared over n cubed. Now that we have our Riemann sum, we can use properties of summation notation to evaluate the sum. Recall that the sum of a difference is equal to the difference of sums, and the sum of a constant times a variable is equal to that constant times the sum of that variable. So, we can rewrite the sum as a difference of sums, and then factor out the constants. Recall that we know formulas for the sum of I cubed and the sum of I squared. So let's substitute those expressions for each sum. That gives us 324 over n to the fourth times n squared times n plus 1 squared all over 4 minus 81 over n cubed times n plus 1 times 2n plus 1 all over 6. If we multiply in each numerator, we get 324 over n to the fourth times n to the fourth plus 2n cubed plus n squared all over 4 minus 81 over n cubed times 2n cubed plus 3n squared plus n all over 6. Now let's multiply to simplify further. Multiplying in the first term, we get 81 plus 162 over n plus 81 over n squared, and then multiplying in the second term, we get minus 27 minus 81 over 2n minus 27 over 2n squared. Finding common denominators and simplifying, we get 54 plus 243 over n plus 135 over n squared. Now we can use the definition of the definite integral by taking the limit of the sum as n approaches infinity. So let's substitute our simplified expression for the sum. Then we'll use properties of limits to rewrite this limit as a sum of limits. Now let's evaluate. The first term is just 54. Then, with the second and third terms, as the denominator gets infinitely large, the expressions approach 0. Simplifying this, we get 54. So, the value of the given definite integral is 54.